know what is the expression in such scenario. So I hope everyone is aware of concepts of voltage regulation. If I am wrong, then correct me so we can discuss some basics of voltage regulation. If anyone wants, otherwise we will go ahead with formula and solve the problem.
Sir, R cos pi plus X sin pi, sir.
Great, great. Thanks a lot. That is perfect. So expression of voltage regulation in terms of per unit, it will be R cos phi and R in per unit cos phi plus X sin phi. So whoever just answered this, okay, why is it plus? Why cannot we write minus? Just I want to know
The
your
power
level.
factor is in lagging, no, sir. Here
Yeah,
given
yeah, yeah.
0.8 lagging.
Exactly, exactly. That's what I wanted to check. So since the power factor is lagging, we can use the plus sign. Otherwise, if there is no information of power factor is given or provided in the problem, then you have to check. Okay, you have to be a little doubtful in that case to which sign you have to apply, right? So here, and we will solve in the end one problem based on leading power factor where negative sign will be handy, and why that will come, that will see. So yeah, so this is the expression as he has mentioned. So we will move ahead with this expression and we will solve this problem. And this expression is coming basically, the voltage regulation expression is nothing but E2 minus V2 by V2. It essentially what does imply that whatever, how much quantity of voltage is being reduced at the loaded condition as compared to the no load condition, right? So E2 is the no load condition, right? And V2 is the voltage after the load. And when you load certain transformer, because we use transformer to supply certain kind of load, we do not want to operate it on no load. So because of the characteristics of that load, how much voltage drop will occur in the circuit or in the machine, so that we need to figure it out. So that is the physical meaning of this expression. So we have the expression of RPU cos phi plus XPU sin phi. So, and in the problem, it is provided RPU is provided, right? So RPU is provided 3%, that we can write 0.03 PU. XPU is not given very directly, right? So we can calculate it from ZPU. So ZPU is given 5%. So that we can write 0.05 PU. So if you compute XPU, okay, if you compute XPU, it will be nothing but ZPU
4 pu.
square. Yeah, yeah, correct. It is very common example, 3 and 5, so it will come around 4. So if you compute it, it will be 0.04 unit. That's very correct, yeah. So XPU, we have ended up with 0.004 per unit. Now, power factor is given. It means indirectly cos phi is given. Cos phi is 0.8. So how much will be sin phi? You might remember this particular data.
0.6.
0.6, exactly. So that is a characteristics of who is rigorously preparing for the gate. They might be, it might have been set up in their consciousness that if cos phi is 0.8, sin phi is 0.6. Or yeah, and in gate generally they use very commonly used data frequently. So that's another thing, and that's another way to save your milliseconds and some seconds in your gate exams. Yeah. So having said that, now we can compute the voltage regulation, right? As we have this expression, I will highlight it with expression 1. So RPU is nothing but 0.03 into 0.8. plus xpu is 0.04 into sine phi is zero point 0.6. So how much it will come out to be? 0.024 it should be, I guess, and it will be also 0.024. So it is nothing but 0.048. So voltage regulation, we ended up with 0.048. What is it? What is this value? 0.048. Which value is this? Percentage, exact value? What is it?
Per unit, sir. That
Sorry, could you please repeat?
here 4.8 percentage, sir.
4.8%, exactly. So this, whatever we computed with the help of RPU cos phi plus XPU sin phi, if you recall the derivation, so in denominator V2 is always present. That's why the RPU is coming. And hence, this, if you convert into percentage, you just have to multiply with 100. So it will be 4.8%. And that should be the answer to this problem. Okay, any doubt in this problem?
Sir, will you give it once again overview?
Okay, you want an overview of this particular problem or this topic, basically, you mean?
Yeah, this topic.
Okay, this topic. So, see, I will just quickly cover it, okay, just with the help of phasor, what happens exactly, okay. Let us say you have a voltage, okay, which is at no load, okay, and I am denoting it with the help of E, an EMF, okay. Now, what will happen when certain load will be applied? So, if let us say lagging load is applied, right? So it will have some angle lagging by E. If now at this load of current I, we will have to identify the value of terminal voltage. Because of this load current I, how much will be the terminal voltage? Okay. So that terminal voltage, according to phasor, you have to draw a perpendicular vector to the I vector, right? And if you join this, you will get V. Okay. So the difference between this E, which was at no load, and this V at any particular load, okay. So how much percentage change is occurring in them, right? So that is essentially the voltage regulation, right? Did you get a quick overview? Did you get, or do you have any quick questions on this?
No, sir, it's clear.
Okay, thanks a lot. So it's clear. In between, we will solve some problem. Okay, this particular problem is not based on voltage regulation, but we will come to this problem. This is a very interesting problem. So this problem straight away asked for 1 mark in GATE 2007. Okay, just based on our theory that in
See,
a
sir.
C, yeah, exactly, C, and we will see why it is C. Okay, so in a transformer, when does zero voltage regulation occurs? So if you derive or even from the expression R cos phi, just now we solved, plus X sin phi. So this was for lagging load, right? And we know by the behavior of this equation that this equation is never gonna to be zero, right? So this will become zero if minus sign will be there instead of plus. And minus sign will come only when our load is leading power. Load is operating at the leading power factor. Okay, so whenever leading power factor load is there connected to the machine, then only there is one possibility that zero voltage regulation may occur. It is not certain, it is not guaranteed, there is a possibility that it may occur. Okay, or or it can go into negative. Voltage regulation can go into negative. What does negative sign imply here? When voltage regulation of your machine is becoming negative, what does it imply? Physical meaning of this negative sign? Could anyone elaborate?
Sir, negative means it consumes or it not consumes. That means is generate the power. That means
Yeah,
it's negative, but it's not practically
yeah,
possible.
yeah. No, it is practically
It
possible if you
means
connect
that
a leading load. Yeah. Any other answer? Any Anil want to answer this?
so it means that current is leading.
Mm-hmm. Yes, correct.
Current
Current
and
is leading, and
when voltage is lagging behind the current. That's it.
okay. So, see, what happens when leading load is connected? So basically, your voltage will whatever at whatever the voltage was initially at the no load, and at the moment you loaded, your voltage is becoming higher than the no load voltage, right? So negative sign basically imply that your voltage regulation is negative. It means E2 minus V2 by V2 is less than 0. Okay, so it means E2 by V2 minus 1 is less than 0. Okay, so E2 is less than 1 plus V2. So, like in that case, your V2 will extend the E2. That there might be some possibility that it will be close to V2 at zero voltage regulation, but there is a possibility, and there is high probability that your V2 will extend E2. So when we will solve, yeah, anyone is saying something? Who is saying something? Yeah. Okay. I think I did hear some simplification mistake. Yeah. So if you shifted this side, so E2 will be less than V2. This equation is just. Uh, did you want to point this thing, or you had some other question? Okay. So from this expression, we got to know that in leading power factor, okay, our voltage regulation can be zero or can be negative, and its physical meaning it's just that your terminal voltage at loaded condition will be higher than the no load condition. Is that clear? So for this part, option C is correct. Okay, great. So let us move ahead with one very interesting problem. Okay, I hope you are able to see this problem. So read it once very clearly. Okay, I know as soon as we see a three-phase thing in our machines or anywhere, we get a bit scared, but there is no need to get scared. And it is very simple problem. Okay, just one step multiplication. That's it. So I want from you guys that you lead me to an answer for this problem. Any suggestion? It can be wrong. Okay. Basically, during the preparation, we do 99% times wrong only. So no need to fear that it will be wrong or what. You just have to, whatever you are thinking after reading this problem, you just have to let it out. Anything.
So for short circuit test, we need to give less rated voltage, no, sir.
At short circuit test, you are saying we have to provide rated current, right?
A rated current, but less voltage.
Less voltage. Yeah. So short circuit test is done on the low voltage side.
Yes, sir.
You see from the problem with low voltage terminal sorted. Okay. So in that case, it is a very specific case when half the full load current during the short circuit test is being conducted with low voltage terminal sorted. What will be the applied voltage on the high voltage side? So what happens when short circuit is done on either side of the transformer?
Short circuit current into impedance on high voltage source.
Exactly, that will be the answer. Because in the condition of short circuit, you do not have any load. Okay, you do not have any load. Means you do not need to worry about load impedance. So whatever you will get, see, you have to apply a voltage that can cater the requirement according to this problem. Okay, so when zero point 0.5 of full load current is flowing at that time, how much voltage will be required? So it will be simply voltage will be zero point 0.5 IFL into Z. Okay, am I right?
Sir, point 0.5 volt.
Yeah, 0 0.5 volt you are saying. Okay, we have to see how much, but zero point 0.5 volt will certainly not an answer. Okay, so I know why you are saying. You are saying I full load will be one and Z will be one, but Z is here given 4.5%. So there is two way. Okay, there are two ways through which you can go. That either you compute full load current. Okay, now you refer the impedance to the primary side. Okay, and after doing that all, you have to take care of factor of root 3 and all because it is connected in delta primary, right? So it will consume a lot of your time, and time is very precious in such exam. So if you are very well versed with the concepts of per unit and voltage regulation, so this question test your knowledge of short circuit test. Okay, three-phase transformer and per unit concept and voltage regulation. So you have to be very well aware with all those four concepts, and you have to know how to apply all four concepts and just simplify this problem. If you don't know any one or two, let us say if you don't know the concept of per unit thing. Okay, so what you will do, you will compute everything and bring them in actual format, and then you will refer to the primary side, and then again you will calculate everything. But if you know half the full load of current is flowing, the same current will flow on the primary side as well in per unit. So I can write it simply 0.5 I full load into Z per unit. Okay, into V base. Right? Am I right? Any doubt in this expression?
No, sir.
Great. So yeah, uh, zero point 0.5 I full load, we know 1 per unit. ZPU is given in the question 4.5%, so it will be 0.05, 0.045 into V base. Okay.
Sir, why V base is included? Sir?
Yeah, because all of these parameters till this point you are computing in per unit terms. And for answer, we need actual value. I hope you are able to see the question. The,
Yes, sir.
the applied voltage on the high voltage side will be how much? So it is required in volt. And I think I have taken from any third party source. I have picked up this question, but in exam it will be clearly mentioned that you have to enter the value in volt also. So do not worry about that if you missed that point. But from the context, you can guess that it is asking for actual value. So till here, if you multiply 0.045 into 0.5, 0.5 into 0.5, so I am getting 0.0, sorry.
Sir, how did you calculate 1 per unit I for load?
Full load value is always per unit, no? At rated condition of voltage or current, if you know that full load, this machine is operating at full load, it means current is 1 per unit, isn't it?
No, sir.
No. Okay, so what will happen according to you?
Sir, high I rated is equal to V rated by impedance rated, right?
Okay, yeah, I rated is equal to V rated by Z per unit. Oh, sorry, Z, right? Yeah.
Then, sir, how we can calculate it from here?
Here in the question, Z is given. Okay, so if you are you want to see simply, if you cannot, first thing is that you cannot just go ahead with this expression. Why? Because it is dependent on load. Okay, I rated is not a constant thing. Means current is not a constant thing. Rated value is fixed, but how much load will draw the current, that is not in your hand. Okay, so rated means what? What do you mean by rating? If any machine is identified on the nameplate with such rating, such a voltage rating, such a current rating, what do you understand from that terminology?
It is the maximum current or some voltage that can handle the by the machine.
Yeah, and even if I want to extend it further, maximum can extend this rated value by very small margin. Okay, so rated value is that machine can endure that kind of load without any problem. Okay, so that is generally termed as rated, and rated we identify every time kVA rated divided by V rated. Now kVA rating, you if you are solving, or you if you have been solving, you might understand by now that whatever rated kVA is provided for a single machine, that we generally consider as one, right? kVA rated, we generally consider it as one per unit, and V rated, obviously, we generally consider it, right? I am using the term generally consider it. You can take any value if you want, but once you have taken that value, you have to stick with it. But this is the general practice that we use. Okay, so if you don't want to consider full load value as one, then you have to scale that all those value, but that complicates the system. Okay, and we don't want to entangle ourselves in such things for such kind of exam. So we generally simplify things with the value one. One is very sweet value. Okay, it is very easy. You can multiply, the value will remain same. If you take any other value, 0.2, 0.3, it will complicate the things. So I hope now you are able to follow why I am saying I rated is equal to 1 pu.
Yes, sir, I got it, sir.
Okay, great. Thanks a lot. So I was at this point. Here I'm getting 0.0225 into V base. Now, what will be the V base? We are just one step away from our answer. Okay. So this was one step where we had to write our expression. Okay, now I am just plugging in all the values and I want to find out my answer. So what will be the V base? Had you referred all the things and you had simplified, you had to take care of all the root three things since we are dealing in delta and stuff. But now you do not need to do such thing, because here 11 kV is given, it is line value RMS. And if there is nothing mentioned for answer, you have to always give answer in line value RMS. So now tell me how much will be the value of base voltage so that we will get the answer.
Sir, 11 kV.
11 kV, exactly, because that uh, voltage will be applied on the high voltage side. So we have to straight away multiply with 11 kV. Right? So 0.025 225 into 11,000. So how much you will get? That will be your answer. How much it is? 247.5. So that much voltage you are applying, you have to apply at this particular condition of during this kind of test, right? However, the rating of this primary winding is 11 kV and we are operating at 247.5 volt only. So we can operate at any value, but rating will be maximum, right? As one guy said, that rating is the maximum value, right? So I hope this is clear to you guys. Any doubt in this part?
No, sir.
No. Okay, great. So I'm revisiting this problem, which was asked. By the way, this last problem which we solved, that was for 2 marks, okay? And this problem which we will solve, that is also of 2 marks. And this is very interesting problem. It just check your basic network and you know the flow of power between leading, lagging, right? So kindly read this problem very carefully. And we have to provide the value of reactance to improve the input power factor to unity. So we have to maintain the unity power factor of this circuit. Okay. So first thing is that I want to know from you guys, how do we maintain unity power factor? What is the criteria of unity power factor? And
By
do not,
maintaining only resistive loads.
by maintaining only resistive load. Yeah, you are correct. But why only resistive load? What means, I want to know, you are correct, okay, you are correct concept wise, but I want to know the reason behind it, right? Why
Because
resist?
only in resistive load, the voltage and the current will be in phase. In all other cases, it will be lagging or leading, so that will not get the unity
Exact,
power factor.
exactly, but in this circuit we have a lagging load, right, along with a resistor. So how is it possible to maintain unity power factor?
Sir, in this circuit, this is the
Hmm.
lagging circuit, so that
Yes,
we can attach the leading power factor to get the leading power factor or to unity to neutralize both the lagging, and lagging is equal to the leading. That means we need to attach here capacitor.
exactly, that's perfect, Sandeep. That was exact answer. So let me simplify it for you guys. So the circuit will operate at unity power factor when, if you have attached a lagging load, then you have to provide a source of lagging load, right? So that source should be leading load power factor operable parameter or element that should itself supply that much of reactive power to your lagging load. So any additional burden on the supply should not be there. Supply should be there only to provide the register, right? So if in your load, generally in fan load or any kind of load, you have resistance as well as inductance. So you have to attach, you have to include that element that should be able to cater the only reactive component of that load demand. Okay, you do not need to worry about resistive, because reactive power generally we know it as useless component, but it is not useless exactly. But from the power factor perspective, it is useless. Or basically, to be more precise, it is deteriorating our performance of the power factor from power factor perspective. So we want to eliminate the effect of that inductance or lagging thing. Okay. Similarly, if you have any capacitive load, then what will happen? Assume that you have a circuit in a manner where resistance and capacitors are present, and your load is becoming leading. In that case, also it cannot operate at unity power factor. Then you have to provide an inductor kind of source, okay, source of leading power factor, which will be lagging power factor element. Okay, so that could provide, or that could supply to leading power factor in terms of lagging power factor. So it becomes a bit confusing. I'm using leading and lagging very interchangeably, but it is not confusing. If you have a load of leading, then you should have source of leading. Okay, and its nature should be lagging such that it could cater to the leading. So that's why in machines, if you study motor and generator, you get confused. You will get confused definitely if you will read the book P.S. Libra. You will see that this term of leading and lagging are very interchangeably used in there. So there, in a manner, you can see that source is supplying reactive power, leading reactive power to the load. So it is very generic, interchangeably terms. So basically, you have to identify what is the nature of load and what does it demand. Okay, I hope it is clear. If it is not clear, I can elaborate it, but I do not want to extend very much. So you have to let me know so that we can move to the solution part.
Sir, if his load is lagging, source nature is leading, and source also lagging, sir.
Yeah, source nature should be such that it can supply to the lagging load. If you have lagging load, okay, so it requires lagging kind of power, lagging nature of power. So it requires, and that can be provided from the element which has leading reactive power in their nature. Like for inductor load is lagging, right, as provided in this question. And this lagging reactive power demand will be supplied from capacitor or capacitor type of load, who will supply this lagging power, because it is a leading power factor element. So another inductor cannot supply this lagging power factor, right? So it has to be something which is leading in itself in nature, and it can supply to other required, or load which is demanding. So it has to cater the demand. So that's what I mean. Is it clear?
Okay, sir.
Okay, great. So let us move ahead. So as Sandeep mentioned that here this element X element should be capacitor. Let me change the color. So this X should be capacitor. I hope it is pretty clear why we are saying it is capacitor. Okay. Now, now we have to come to the solution portion. Okay. Now we got the meaning of this problem. Okay. What it is asking, but how to solve this numerical problem? This is a numerical problem, right? So how to solve this problem?
Sir, I think here the rating was 4 kilowatt, and
Rating. Rating is 4 kilowatt. Yeah, you are
and
correct. Good.
lagging power factor is 0.89, so that
Yes.
we can find the effective power absorbed, that is 4 kilowatt into 0.89, that is 3.56 kilowatt.
Mm-hmm.
After that, in this circuit, given circuit, we can
Mm-hmm.
find the V2 by uh, dividing 3.56 kilowatt but by 110, that is
Okay,
the
so
V2, 32
sorry
56.
to interrupt you in between.
Okay, sir.
So if you multiply 4 kilowatt into 0.89, I don't think it will lead to some useful result. I think you mean divide it by 0.89, right?
Yes, sir. Yes, sir. Sorry, sir. Yes, yes.
Okay, okay. Yeah, thanks for clarifying. So if you divide it, it will come to some kVA, right?
Yes,
And let me do it for you. 4 divided by 0.89, it will come out to be 4.494.
yes. Okay, sir.
494 kVA. Now you can go ahead after this step.
Uh, then we divided by 110 in the given
We
circuit.
di- okay. We will divide it with 110 volt.
Then we get the V2 primary side for 40.85 volt.
Uh, so if you divide it with 110 volt, it will lead to certain current, right?
Yes, sir.
So that current you are saying 40 point something.
Yes, sir. Yes, sir.
Okay. So how much is that current?
40.85.
So let me tell you, everyone who is conscious till now. So this is I2. Okay. So what we are doing, what essentially Sandeep is doing, he is dividing the power factor from the load power, and that is becoming 4.494 kVA. And after that, we are dividing it with 110 volt. So now we will get I2 value, and that is uh, 4494 divided by 110. That will come out to be 40.85 ampere. I hope everyone is able to follow. If anyone did not get, please let me know just now so that we can clarify it right now. Till this point, I hope it is clear for everyone, right?
Yes, sir. Next turns ratio, sir.
Yeah, next is turns ratio. Exactly. So now we have found this I2 current. Next step is we have to find this I2 dash, this current referred to the primary side. Right, Sandeep?
Yes, sir.
Yeah.
Twice of
So it will be how much?
twice of I2.
No, I guess it should be half of I2.
Yes, half of I2. Yes.
Half of I2, yeah. So it will be 20.427 amps. Yeah, so we have reached till this node. Okay. And on it is not only current. Okay, you have to be aware that with a power factor of cos inverse 0.89. Okay. So uh, please let me know how much is this power factor angle. I want to deal in terms of angle only. Okay, so I have calculated. It is 20.
27.12.
Okay, thanks a lot. It is
27.12.
27.12. Okay, so this much current is there. Okay, now since we have shifted into polar coordinate, okay, now this this quantity will have a real component and the imaginary component. Okay, and that imaginary component, let me break it for you first. So the real part will be how much? Could anyone let me know quickly how much will be real and imaginary part? You just have to break it into complex terms.
18.21.
18.21. and minus
minus 9.31 iota.
9.31. Great. So it is your current which is flowing here. Okay. Now this is the load current being seen from the primary side. Okay. And we have a real component that is fine from the perspective of maintaining unity power factor. Only we have issue with this imaginary component. Okay. And since this is a lagging, so we have to apply a leading power factor source element. So that could oppose this J 9.31. Okay, so let me draw a graph for you in here. So you applied a voltage, okay, which is applied here, a 50 hertz source. You can see, right? So that is source V. You have some current lagging. Okay. Always visualize in terms of phasor. It will make your life simpler. Okay. This is your power factor angle. That is nothing but 27.12 degree. Now, this current will have a component along this V. Okay, let me change the color so that this component will have here I cos phi. Essentially, it is I cos phi we have computed, right? 18.21. So this is 18.21 ampere here at this point, and it will have some imaginary that will cater to reactive powers. So it is how much? We have calculated already. You just have to let me know how much is it.
9.31.
9.31. So it is 9.31, and this is creating a trouble to maintain unity power factor. So we just have to apply an opposite current of same magnitude, okay, of 9.31 ampere, such that it will cancel the both terms, and we will end up with only 18.21 ampere. Is it clear till this point? Any doubt?
Clear.
Clear. Great. And this 9.31 ampere and 18.21 ampere, this is here I2 dash. Okay. So do not get confused. Now we have referred everything to primary side. So now we have to apply this X element such that our current will be supplied from this X element that should be equal to 9.31 ampere. Okay. So this X should supply 9.31 ampere, and that should go to all the way from primary to secondary to load. So here 9.31 ampere. I am not indicating real component here. I just want to focus on reactive component. Okay. So that's why I am writing it 9.3 ampere. However, this notation is wrong. I should not write it in that manner, but I just want to make it, very convenient for you. So what I essentially means that this lagging load of, you know, uh, 20.427 ampere, this 9.3 ampere is reactive component of that current, and that will be supplied from this capacitor. Okay, so this is the way. So there, in that manner, your source is not getting hampered and its capability is not getting reduced. That, if you have certain kVA, we have computed 4.494 kVA by the capacity of this transformer, right? And with the inductive load of 4 kilowatt with 0.89 lagging, we have reduced it to 4 kilowatt. So that reduction will not be there, and it will be supplied from your capacitor, right? I hope you are getting, or you will appreciate this physical meaning of this question. Now, this 9.31 ampere we know, and we know the voltage at this point, right? How much is the voltage? Can anyone let me know how much is the voltage at primary side? You just have to refer it, right? 110 volt, you know, on the secondary side, which was connected to load. You just have to refer it to primary side.
E2 into N1 by N2, sir.
Yeah, so basically 110 into, let me write E1. E1 by E2, I hope you know, is equal to N1 by N2. So E1 will be 110 into 2 by 1. So it will be 220 volt. Okay. Now we have voltage, we have current, we can easily identify the value of this reactance. So this X is equal to V by I, 220 divided by 9.31 amps. And that is how much? That is 23.63 ohm, right? And to make it more informative, you can write in terms of minus J, right? So if further in this question, they could have asked what will be the value of capacitance, that, or what will be the value of the particular element, not reactance in ohms. What will be the value of either capacitance or inductance? Since they are not revealing whether it is capacitance or inductance, so they could have asked what will be the value of capacitance or inductance, that element. So that you could evaluate according to 1 by omega c, and c will be 1 by 23.63 into 2 into pi into 50 hertz they have mentioned. So whatever the value it will give you, that could have been the answer to that question, that imaginary question which we just discussed. Okay, so there are many ways to tweak the question, or no, maybe they could have made it, common answer type question, common data question, right? So common data question should have, if you corrected first part, then only it is guaranteed that you can correct second part. If you have not done correct answer for first part, it is guaranteed that you will miss on second part. Yeah, anyone want to say something?
Sir, here, what is power factor, sir?
Source power factor, we have maintained unity now, right? Earlier it was 0.89 and
Okay.
okay, I got your point. So you want to know the difference between load power factor and source power factor.
Yes, sir.
Yeah. So in this circuit, okay, in this circuit, there is no any difference in load power factor and source power factor that appears in power electronics converters. Here it is whatever is required at the load that will be supplied from the source. Okay, there is no any other source, okay, who will interrupt in between and that will provide to your load. So here whatever will be your load power factor, that will be so, and here we do not have any harmonics. Right, in power factor, harmonics come in picture. That's why whatever load power factor is there, that doesn't become equal to source power factor. But here there is no harmonic. We are just analyzing with the help of fundamental. So whatever load is demanding, that you are catering from the supply directly. So that's why both will be equal. Is it clear?
Okay, sir. Sir, another one doubt, sir.
Yeah, go ahead, please.
Sir, what is your transformer utilization factor, sir?
Sorry,
In the
which factor?
transformer utilization factor, sir. TUF.
Transformer
हेलो
transformer utilization factor.
ऐसे
Okay,
क्या
so
ऐसे
basically, I think
লোকেশনটা যদি
Sandeep
পাঠিয়ে দিতে আমি চলে আসতাম
is
কারণ আমি লোকেশনটা জানা নেই
okay. So I have muted him. So transformer utilization factor is something that with that parameter you identify how much your transformer is getting, how much useful is your transformer, right? So I hope you know the expression, right? You know the expression. Who asked this? I think Koteshwar asked this.
Yes, sir. Yes, sir.
You know the expression of transformer utilization factor?
I have little idea about that, sir. Total load by working load, something is there, sir.
No, no, no. That is not exact. So to be exact, the transformer utilization factor, let me change the color. So transformer utilization factor is how much power you are getting
So
at
output power by
output power by,
effective rating of transformer. So
yeah, effective rating we deal in terms of kVA.
yes,
So
sir.
yeah, so what, how much rating of your transformer is being utilized? Just like we saw here, that rating of our transformer was how much? 4.494 kVA. So you can compute TUF. How much will be TUF for this particular question which we just solved? 4 by 4.494.
4.494 K. Okay, okay,
Yes.
sir.
Yeah. So how much you are utilizing it? And
0.89 floats.
yeah, 0.89. So 89.6% as you are utilizing. But
Okay, okay.
this scenario will change once you enter into power electronics domain. Okay, so there will be some power will be lost in harmonics. So that you have to also account. Okay, so do not worry about that. So this is the utilization. How much is it you utilizing, right? So when you are studying, just worry about that particular topic you are studying. Okay, if you think of all, then you might get tensed. But when you are solving, then always try to recollect all of your concepts from all the subjects, like we did in the last problem, right? In three phase, and in many questions they generally link two, three subjects, four subjects, right? So that is no need to worry. That is basically sharpening your concepts from whatever you have learning earlier. Okay, so any final doubt till now? And I will leave you guys with a problem which is a bit lengthy, but I want you anyway to go ahead and solve this problem. Okay, and I will upload these slides as well as video on my YouTube channel. These slides will be given in terms of link in the description box. Okay, I hope you are aware with where I upload all my content. So let me write it. Where do you get? Okay, so go ahead and solve this problem. This is a bit lengthy, but it gives you patience to not commit any mistake at the same time to learn with new concepts. Okay, so this you please correct it. It is home, right? So let me give you the link of that. So I have dropped the link in the chat box. You can go to the link, or you can search uh, JDS at the rate IITB. Okay, so you will get. So I hope you will try this problem, and you will let me know the answer in the next session. Okay, I want answer for this problem, both part, and that will enhance your preparation. Yeah, any final doubt before winding up the session?
No, sir.
Okay, great. Then thank you very much for attending. Have a nice day or good night. Okay, bye.